north and south straightaway.
It's all very interesting. But what is this place?
Well, it's a place for finding things out.
What things?
Haven't you just seen that even the wind that blows here and the rain that falls here are measured? And so are the wheels.
But why?
Simply as a necessary part of finding out everything there is to know about automobiles. Not only these automobiles, motor cars from all over the world are brought here to be tested on this great proving ground. Over 1,200 acres of measured roads and man-made grades with unlimited facilities for scientific testing. Driving the car is the only way to find out the really important things. You can't find a defective ignition system on a drawing board or night visibility on a blueprint. That takes driving, outdoor and indoor driving. Yes, indoor driving. What's the idea of indoor driving? It's the idea of testing cars on giant yardsticks with exhaustive tryouts which measure the exact results of every improvement that is made. Here, for example, they're measuring the car and all its dimensions. That's one of the first things they do when they want to find out how the car is going to behave, how it's going to react to all kinds of wind, weather, and engineer has to sit down and figure out the puzzle known as the car's center of gravity. If that elusive point is too high, the car will be easy to roll over. If it's too far forward, steering is difficult. How many swings before they know the answers? Well, 1,000 times, back and forth, gives enough information to figure out the exact center of gravity and make sure you'll be safe on the turns. Each part has a secret, a problem that engineers are mighty anxious to know about. What's this? A mechanical merry-go-round? Combined in the car as a united whole, these parts present many hundreds of questions that must be answered. What are these questions? And what are the answers? Well, first, will this car go places? To find that out, the power must be measured. The chassis dynamometer is a fascinating device that measures the force or work done and the horsepower, the rate of work done at the rear wheel tire running on a paper drum. On the panel board is a maze of controls and light switches and a lot of important gadgets such as a temperature gauge, the voltmeters and ammeters, and the U-tube, which measures the vacuum or pressure. Once these results are determined, they are carefully recorded. Then they must try out the car in order to investigate its power in action. It's tried out on level ground, the straightaway, and on all kinds of grades. At low speed and high speed, each car has to give an account of that power plant under the hood, because that's one of the big things the owner is interested in. These engineers aren't content to say, sure, it's got a powerful engine. They want to know. Each mile brings them closer to the truth. Each hill answers another question. And at the end of the test, the careful engineers know, to the fraction, the amount of power the owner's getting for his money. Will the car go places easily? That's a question every driver's interested in, because nowadays most of us expect to get pleasure out of driving, and we want everything to be made as easy as possible for the fellow in the driver's seat. For one thing, easy parking is important. And to find out whether or not the car is going to slip into a small space at the curb with minimum effort on your part, the shorter turning radius must be verified. Every car tested at the proving ground must go round that circle, and it's a vicious circle for any car which cannot measure up to these requirements. To make this test, you have to use an extra steering wheel. See this queer-looking double wheel? The one on top is an auxiliary wheel, clamped over the regular one. Between the two is a dial, which shows in pounds how little effort is required for turning. It's queer-looking apparatus to be steering with, almost a two-headed calf, but it gives the answer to a mighty important question. Since quick getaway is a part of easy driving, acceleration must be measured. And to tell just how fast the four wheels are speeding up, a fifth wheel is added, the pulsometer, accurate in diameter within hundredths of an inch. The accelerometer, or printing chronograph, is used in connection with the fifth wheel. It's a kind of automatic printing machine working on the principle of the ticker tape. It electrically records getaway with uncanny exactness. Acceleration is checked on all cars from 5 to 25 miles per hour in low gear, from 5 to 45 in second, and 5 to 60 miles per hour in high. All so that fast getaway can be definitely known and certified. On rough roads, easy driving gets its tryout. Every series of bumps here has been measured, and the bumping characteristics of each stretch of road are known to the proving ground drivers. If the car handles well while going through these paces, it gets the engineer's approval for easy driving. We must know, too, if the car will go places easily and comfortably on all kinds of roads, whatever the wind and weather. So, another important thing to discover is, are there any drafts getting through around windows and doors? In the search for air leaks, this suction pump, which they call the elephant's trunk, is used. The elephant's trunk is really an enlarged vacuum cleaner with plenty of cleaning capacity. The air that is drawn out is measured and compared with the amount of air drawn out when all the openings in the body have been sealed up. The difference in the air measurements shows whether there is any leakage and how much. This part of the test helps to locate the leaks, if any. The smoke is applied to the edges of doors and windows, and if no smoke is drawn in, the engineers know there's no chance for cold air to get in, nor for warm, comfortable air to get out. A lot of attention is being paid to the subject of controlled individual ventilation nowadays, and the engineers are going after it with every ingenious device at their command. If they say the car is draft-proof, the owner can be sure he's protected from the weather, even if it did take an elephant's trunk to find out. No draft ventilation has to be verified along with everything else. It gets tested in heat and cold and rain. And as a grand climax to all the checking of weather comfort inside the car, one of the toughest of all takes place in a bathtub. There mustn't be any cracks around doors or windows or floorboards if things are to keep dry and snug inside the car while this test is being made. The desire for greater riding comfort for driver and passenger inspired the ingenious spring rate test, in which the weight of the wheels of the car, loaded and unloaded, is measured on separate scales. The results show how far each spring goes down under a certain weight. The rate of deflection, it's called. And that's a very valuable thing to know when you're building more comfort into an automobile. To learn more about the overall riding characteristics of the car, they have a road built of Belgian paving blocks. Here on the Belgian blocks, knee action gets tried out and proved, along with all other cars, so that the engineers can know the reactions of the passengers in the rear seat. And now, will the car go places easily and comfortably with safety? Visibility, the angle of view from each side, as well as to the front and rear of the car, is becoming more and more important as a safety factor. At the proving ground, shadows of the automobile body are thrown against these squares by two light bulbs inside the car, placed just at the height of the driver's eyes. All shadows on the squares represent interference with the driver's vision, and each black shadow is faithfully measured and recorded and studied in order to cut down the amount of interference. In night driving, visibility is really safety factor number one, because all the safety appliances in the world couldn't help the driver if he didn't see the danger. Stop, look, and listen. And the looking calls for visibility. Being able to stop quickly when you see an obstacle on the road is just as important as being able to see it. So brake tests are made with stops at 20, 40, 60, 70, and higher, with thousands of other stops at low speeds and high speeds. Each stop is measured. Each stop is checked by this device known as the decelerometer, which records the exact amount of pressure on the brake pedal. Because the pressure of the human foot varies, air pressure has to be used to get uniform brake pedal pressure on all stops in a given test. What you might call jamming on the brakes means a certain amount of pressure to the engineer. This man can tell you just what it took to stop the car with the brakes at a certain temperature and a certain humidity at a given rate of speed, and even in what direction the wind was blowing when he made the test. To ensure the safety of the man who will own the car, tests for quick stops are made in fair weather and foul. Nothing is left unchecked that might help to determine the stopping power of the car's brakes. The next question is, will the car go places easily, comfortably, safely, and economically? To measure the miles your car will average to the gallon, that dependable fifth wheel is used again in a very painstaking and accurate test, showing exactly the amount of fuel used by the cars down to the last drop. One of these tubes is filled with light-colored gasoline, and the other tube with gas of a darker shade. In this fuel economy test, the indicator for the darker gas is set at 0, and this gasoline is consumed only during the actual test. The gas in the other tube is used for the approach to and return from the test and in between the experiments. The observer clocks the speed with his stopwatch. The electrical speed indicator in the driver's lap is connected with the accurate fifth wheel. Here we go, with everything under scientific control. Increased fuel economy is verified by the most precise measurement. There's no guesswork about how much gas is used by the finest modern motor cars. Ease, comfort, safety, economy, all thoroughly tested and proved. How will a new car just like this test model perform for the owner after tens of thousands of miles? Will every part deliver all the mileage for which the car is designed? Mile after mile piles up. Every condition of wind and road and weather is encountered. Each hour of relentless driving adds its bit of information and evidence. 25,000 miles is the first goal. In 2 months of this going, that rolls around on the speedometer. But long after that, the durability run goes on, hammering and buffeting the car for endless hours, demanding more and more proofs of lasting stamina and enduring performance. All the answers to all these questions and to hundreds of others are reduced to graphs, scales, and records of facts. Definite, exact, precise information checked by the scientific application of 1,000 intricate measuring sticks in the greatest outdoor laboratory in the world. And so, before each of the long succession of progressive improvements is introduced into the new models, they are all tested and measured and checked. Progress through constant improvement, but always with improvements which have been tried and certified. All this to contribute to the development of the finer modern motor cars, one of the highest expressions of the ability to achieve great things for the convenience and safety of others, the outstanding triumph in the scientific and industrial leadership which has made America the pride of Americans and the envy of all the world. And that's why these men are always at it, in wind and weather, the wheels keep turning. Day after day, hour after hour, year after year, questioning, seeking, examining, and finding out.